Hello, I'm Mrs. Neill, and this is geometry lesson number 1, points, lines, and planes. If you notice, listed right here is the vocabulary that we're going to be learning today. Point, line, collinear points, plane, coplanar points, axiom or postulates. This is our vocabulary, and I'll be giving you the definition of these terms in just a minute. Now, these are our geometry rules, which I call TAPs. These are theorems, axioms, and postulates, and you'll be learning a lot of those this year in geometry. We're going to go over postulate 1, postulate 2, postulate 3, and postulate number 4. So I'll be discussing our lesson today basically in this order right here. So the first definition we're going to look at is point, and I have this written right here for you. Just save some time. I've already got it printed out. A point is represented by a dot. A point is labeled with a capital letter because when you draw a point, a line, a ray, a plane, you have to label it because you have to know what you're talking about. So if I just draw a dot right here, I'm going to label it with a capital letter A. That's a big letter A. I can draw another point over here, and I'm going to name it B, just for clarity. C, D. What if I keep adding point after point after point after point, and I keep just bam, bam, bam. Look at all these points I'm adding. When they're one on top of the other, that creates something. That will create a line. A line is an infinite amount of points. So, a line is the quickest path to pass between 2 points. A line is labeled as 2 points or with a lowercase letter. Most of the time you label a line with 2 points right here, 2 points. That's what you see most of the time. So if I have an infinite amount of points stacked all on top of each other, I'm going to draw a line right here. Now, these arrows are very important. This arrow shows me that the line goes on forever and ever and ever. It extends way out to my right, goes on forever. It extends way out to the left, and it goes on forever and ever and ever. If I didn't have these arrows right there, that is not a line. That is a line segment. And we're going to get to line segment next section. Or if I just did that, that's a ray. But we're not doing rays today. We're going to do rays in lesson number 2. So right now we're just looking at lines. Now I want to name this line. I'm going to label it with 2 points. Since this is an infinite amount of points, you have a lot of choices to make. I can label this very easily, line AB. Now if you notice, I drew the little line symbol on top of it. That delineates that I'm talking about a line there. I could also call this line BC. I can also call this line right here AD. You have a lot of choices. So when you're doing your practice problems, you're going to have a lot of different answers. One person may have one answer, a different name than what you did. That doesn't mean you're right or you're wrong. It means you're both correct. Okay, now, if I had a bunch of points all lined up making a line, they are called collinear. Okay, going back with English, what does co mean? Co means with. If you have a coworker, that means you work with that person. You're side by side. So collinear means they're with the same line. So collinear points are points that lie on the same line. All these points are collinear. Now, for example, if I drew little f or little e, let's put an e over here, and he's way off to the side by himself, he is not collinear at all. You would call that non-collinear. Non meaning not with. It's not collinear. It's non-collinear. Or if I wanted to pick a point over here, I'm going to name him F. That is not collinear or non-collinear also. So collinear are points that lie on the same line. That terminology is really important when you start getting into the basics of geometry. Alrighty, let's go on. Let's talk about a plane. We're right here on definition number 4. A plane, and I've gone ahead and I've written it down already, just save some time. And a plane is a flat surface. A plane is like a sheet of notebook paper. It has length and it has width. It has no depth. Okay, pretend that this totally has no depth whatsoever. So when I think of a plane, I think of a piece of paper. It's a flat surface. A plane is labeled with 3 non-collinear points or a cursive capital letter. So what I could do, here's a point. Let's name him A. Here's a point, B. And over here, you got to go over here, C. These are non-collinear. If you notice, I cannot draw a line to match all these up. I can draw a line there. I can draw a line there. I cannot draw a line. So I know that those are non-collinear. So you could call that plane ABC, or you can write it with a cursive capital letter. Okay, cursive is like your handwriting, and this is how planes are usually written, with a cursive capital letter. So I can pick a cursive letter, let me use M. So I'm going to write a cursive letter. That's kind of like cursive is like what you did when you learned handwriting. It's not a printed letter, it's a cursive letter. So you can describe a plane that way also. Let's talk about coplanar points. We talked about collinear points. Now let's talk about coplanar points. Coplanar points. Coplanar points are points that lie on the same plane. They lie on the same plane. So for example, I've got all these points, they're in the same plane. If I lifted this plane up and I drew point X over here, if you notice, it's not on the same sheet of paper as the other points. So that is non-coplanar there. So your coplanar points lie all on the same plane. Okay, now let's get with our postulates and axioms. Here's another definition. A postulate or an axiom is a statement accepted without proof. Meaning I just tell you that's what it is and you say, okay, and you accept it. I don't have to sit there and prove it to you. There are a few of these that we have in geometry. They're usually at the very beginning of learning about geometry. So this is dealing with our TAPS. Remember, our TAPS was theorems, axioms, and postulates. So we're going to go over 4 postulates real quick. Let's do postulate number 1. Okay, I have this written down just to save a little bit of time. Through any 2 points, there is exactly 1 line. So if I have 2 points, I'm just going to name that one A and that B. I can draw 1 line. that will go through that. The shortest distance is between 2 points. Right here, here's an example. On this example here, you can name quite a few lines. You can name line SQ, MN, A, B. There's several to choose from right there. Okay, postulate number 2. If 2 lines intersect, they intersect in exactly 1 point. So let's say I have 2 lines. This one's A, name that B. Don't forget your arrow. And let's do C and D. They always intersect in exactly 1 point, which would be right here. And let's just name that X. They always do that. So let's look at our little example. It's printed off. If you notice here, lots and lots of examples here. Line MN and line SQ intersect right at P. Line AB and line SQ intersect right exactly at P. Let's go to postulate 3. Postulate 3 says, if 2 planes intersect, they intersect in a line. All right, this is hard for me to draw. So what I've got are 2 planes right here. I've got 2 pieces of notebook paper. 2 note cards. And I'm going to put them together. And if you notice, there are 2 planes and they're intersecting. And when they intersect, this line right here is, the 2 planes intersect, and this is the line that they form right here. So that is postulate 3. Our very last postulate is postulate 4. Through any 3 non-collinear points, there is exactly 1 plane. So if I have 3 non-collinear points, we discussed that a minute ago, right here, A, B, and C. They are not in the same line. Then you can have exactly 1 plane. That is the end of our lesson for today. Thank you for watching.